All right, so for identifying these properties, the first one that I showed you how to identify, you actually don't want it to be in factored form. We actually want it in this original form. And so before I factor or cancel things out, I'm just going to go ahead and find that horizontal asymptote. So HA. To find the horizontal asymptote, you look at the degree of the numerator, which is just the biggest exponent, and you compare it to the degree of the denominator, which is that biggest exponent in the bottom. And either one's going to be bigger than the other, or they're going to be the same. That's going to tell you where that horizontal asymptote is. In this case, the horizontal or the degrees are the same. So where is the horizontal asymptote for this one? Or what do you look at? Yeah, your coefficients, which are the numbers in front of each of those square terms, the leading coefficients. So in front of this x squared, technically there's an invisible 1. In front of this other x squared, there's a 2. And so you're really just making a fraction, 1 over 2. So you're saying there's a horizontal asymptote at 1 over 2. So that's the first step. And that just comes from looking at the leading coefficients because the degrees were the same. If the degree in the numerator were smaller, it'd be at 0, at y equals 0. In this case, they're the same. And so we know we have a horizontal asymptote at y equals 1 over 2, 1/2. Now for the next part, we do want to factor everything. Our numerator, that's the difference of squares. Are you getting a little bit better at recognizing those ones when you see the difference of squares at this point? We've been doing that a lot recently, right? And so that simply factors to an x plus 2 and an x minus 2. The denominator, however, your denominator has this coefficient in front, that 2 for a, which means I can't factor it in the easy way, right? That reverse FOIL, the what multiplies to c and adds to b. Instead, we have to use this longer 5-step factoring method that I've shown you a lot. And so the way that it works is you take a and c, and you multiply those two numbers together. Now, normally I write it up above somewhere. I've got something else there. So 2 times 14 is 28. So basically you treat 28 as like your c just for the factoring purpose. And you ask yourself, what are two numbers that multiply to a positive 28 and add to a negative 11? And what are those two numbers? Yeah, already up on the board, everyone. You could have just repeated, but I know it's early, right? And so those two magic numbers would be a negative 7x and a negative 4x, because negative 7 times a negative 4 equals a positive 28. And when you add those together, you get a negative 11. So that's how I know those are my two values I'm going to use to help me factor this. So that was just that negative 11x. I just kind of split it up into two terms. Then I bring my first term down and I bring my last term down, the 2x squared and the plus 14. And now that I've got four terms, we use factor by grouping, where you group the first two terms together and you group the last two terms together, and you just bring the GCF out of each of those separate groupings. Now in front, I've got a 2x squared and a negative 7x. Well, those both just have an x in common. If I divide out that x, what I'm left with would be a 2x minus 7. In that second grouping, I see a negative 4x plus 14. And just a general rule of thumb that I've kind of been sharing with you that I want you to be looking out for is that if you're factoring a polynomial and the leading term is negative, it's typically you're going to want to bring that negative along with it. So because there's a negative 4x there, I'm going to take a negative and a 2 out, right? Because 4 and 14 are both divisible by 2. So I'm going to take out a negative 2 as the GCF for that second grouping. And then when I divide both of those terms by negative 2, I get a positive 2x minus 7. It's just getting in the way. And now if you look at the two parentheses that I have in there, you'll notice that they are the same. 2x minus 7 and a 2x minus 7. That indicates that one of our factors is going to be a 2x minus 7. And the second grouping, the second factor that we're left with, are basically the two GCFs, the two terms that we brought out front. So there's an x and a minus 2, right? That comes from that x and that minus 2. That gave me my second factor. So back in my fraction, I'm rewriting that 2x squared minus 11x plus 14 as 2x minus 7 times x minus 2. All right, so that's all just factoring that part. That's something that you definitely should practice if you're rusty at it. That should be an essential skill at this point in Algebra 2, second semester. You should be really good at factoring. If you're not, then practice it. There's tons of stuff on Delta Math. You can go on, watch a YouTube video. But at this point, you've got to be really good at factoring. So now looking at that fraction over there, to find the vertical asymptotes, we're looking for what numbers would make the denominator 0, except there's one thing. I noticed that two of those factors are the same. They're going to cancel out, and that's going to give us a hole in the graph. All right, so let's go back. We've got the horizontal asymptote and y equals 1/2. The vertical asymptote is what number would make the denominator 0, because we're not allowed to divide by 0. And after we simplified this, I'm really just looking at this factor right here. And I'm wondering, well, what number that if I plugged it in for x would make that denominator a 0? If you're not sure what it is, right off the, just by looking at this, like, oh, what would make 2x minus 7 a 0? You can always just write like a mini equation. Say, all right, well, let's set it equal to 0, and then just solve it for x. Like add 7 to both sides. That gives you 2x equals 7. Then divide by 2. So x equals 7 divided by 2. So we've got a vertical asymptote where x equals 7 halves. 7 over 2. Questions on finding the vertical asymptote? Pretty straightforward. Just like how you would solve a quadratic equation by factoring. Okay. Now the next thing we'd want to identify are any possible holes in our graph. And a hole is going to occur if after we factor it, if something cancels out. And sure enough, something did cancel. So that tells me, yeah, we're going to have a hole in the graph somewhere, just an open circle. Now a hole is a coordinate, an ordered pair, like an x comma y. And the x value is simply, I guess the shortcut to think of it would be it's the opposite of whatever you canceled out, right? I canceled out an x minus 2. And so we're going to get a hole when x would equal a positive 2. Because if x were a positive 2, that would, based on, this part of the fraction here, if x were a positive 2, we would get a 0 divided by 0. And that creates a hole in the graph. And so we know that whenever x is equal to positive 2, we're going to have a hole somewhere. But a hole is essentially a point. It's an open circle point, which means I need an x-coordinate and a y-coordinate. To find the y-coordinate, we're just going to go to our simplified function. So after we simplified, we had x plus 2 over 2x minus 7. So that's our simplified rational function, right, after canceling out the x minus 2's. And, well, essentially, this is our f of x, or our y now. And so if we have an x value and you want to find the y value, just plug that number in, that x, into the equation and see what you get for y. So I know the whole occurs when x equals 2, so I'm going to plug 2 into this equation. 2 plus 2 divided by 2 times x. But again, I'm plugging in a 2 for x. All right, so I took that x value from the whole, from whatever had canceled out, and I'm plugging it back into my simplified function to get my y value. Now, if for some reason you forget to use the simplified function, and if you plugged a 2, like back up here in this original one, you're going to get 0 divided by 0, which should be a trigger to remind you, like, oh, wait, I shouldn't get 0 over 0. Oh, that's right, I need to use the simplified function, okay? Because we should be getting a number. And sure enough, 2 plus 2 is 4. 2 times 2 is 4. Minus 7 is a negative 3. And so negative 4/3. Or negative 1.33333. All right, it's the first 3 properties, right? Vertical asymptote, horizontal asymptotes, and holes. The next thing are your intercepts, x-intercepts and y-intercepts. Where does this graph cross the x-axis? Where does it cross the y-axis? That's minus 7. All right, we can use the factored one to make this easier. And to find any intercept, you simply make the opposite variable a 0. So to find the x-intercepts, you would make the y a 0. Now remember that this equation is equal to y, right? That's f of x. And so you're wondering, hey, how would this whole fraction equal a 0? Well, essentially all we need to worry about is what would make the numerator a 0. Because if I have a fraction that's like 0 divided by anything down here, it's going to be a 0. So I don't really care what I get in the denominator. That can be any number I want. But it's what's going to make the numerator a 0. So I'm taking this x plus 2. I'm wondering, hey, what's going to make that into a 0? And again, that's pretty easy math at this point. You're really just flipping the sign. So we know that, oh, well, there's going to be an x-intercept when x equals negative 2, right? You just subtract 2 from both sides. So we have an x-intercept when x equals 2. Sorry, negative 2. For x, if x is a negative 2, we're going to get a 0 in the numerator, and 0 divided by anything is still 0. So that gives us the point negative 2, comma 0. So that is the x-intercept. Finally, the last thing we need is the y-intercept. To find the y-intercept, it's pretty simple. All we need to do is look back at our equation. You can go to the original or the simplified one here, and you're just looking at, hey, what value, value, basically to find the y-intercept, you just set all the x's to 0, so just cancel out everything with an x. So that's, whoops, let me get a marker. So x squared is gone, 2x squared is gone, negative 11x is gone, and I'm left with this fraction right here, whoop, negative 4 over 14. Right, if I made all the x's into zeros, I'd be left with negative 4 over 14, which simplifies to negative 2 over 7. So I've got a y-intercept when x is 0, because remember, we plugged in a 0 for x. That's why everything canceled out. And we got negative 2 over 7, which is like negative 0.28. So those are the 5 properties of a rational graph. If you are rusty on any of these 5 properties, well, you are in luck, because there's a wonderful Delta Math assignment from Friday that actually specifies each one of these skills in isolation, right? If you just have trouble with identifying vertical asymptotes, you can work on the problems that are just identifying vertical asymptotes, right? Or maybe you just can't find the x-intercepts. So you can focus on the skills to just practice finding x-intercepts, right? It's a wonderful tool for you, but you have to use it. You've got to practice. You've got to try. You've got to put in time outside of class, all right? You're not going to learn this stuff just by sitting here watching me do it. You've got to take part in learning. It's the only way you're going to. All right, so that actually was nothing new. That was from Friday. You've already seen how to do all those things. The new part for today is going to be a bit simpler. It's simply taking these 5 properties and how do we actually graph it? How do we actually get the shape or this curve on a coordinate plane? So these are all of those values that we just calculated. And so in your notes, if you just want to sketch a little coordinate plane real quick, don't worry about it being too accurate. I know in the notebook it's tough to get accurate grid crisscrosses. And so these are all the same pieces. I took all the fractions and I just converted them into decimals, because things like 7 over 2, well, I'm not sure where 7 halves is on the coordinate plane, but I do know where 3.5 is on the coordinate plane. It's a lot easier to graph a decimal than it is a fraction. So those are the same 5 pieces. I'm pretty sure. Can you double check that for me? Are those the same numbers we got? The ones I have up there, are they the same ones we just calculated? Do you see any differences? All right, Frank says we're good to go, so I trust him. He's got eyes. He knows how to use them. He can read things and tell me if they're different or not. He's great at those find the difference puzzles. Practices them all the time. Oh, where's Waldo? Those are good. All right, so we're just going to graph these. I will try to color code them. So starting off with a horizontal asymptote. Y equals 0.5. So an asymptote is just a dashed line. Horizontal means it runs left to right. You go to where y is equal to 0.5, and you draw a dashed line. Oops. So that's right between 0 and 1. Just get it pretty close there. Don't put it up at like 5 or something like that, or 10. Just get it in between the 0 and the 1. I'm not going to measure if it's exactly halfway in between. And again, make sure that you make these asymptotes dashed lines, because they are not part of our graph. They are not the rational function itself. They're simply guides that are going to help us draw the actual curves. All right, now the vertical asymptote is at x equals 3.5. That was the 7 halves, but again, it's easier to graph a decimal. So now this is vertical, meaning it's up and down. So I'm going to go to the x-axis at 3.5. So from the origin, I'm going to go right 1, 2, 3, and then go halfway. I know it's not really halfway. It's my markers. And we're going to draw in this vertical line where x equals 3.5. That's our vertical asymptote. Okay, next is the hole in our graph. And the intercepts. These next 3 things are all just points. They help us know where the curve is going to go. And the one thing to remember is that a hole is an open circle. I need to see that open circle. If you fill it in, that is not correct. So I'm going to go to the point 2, comma, negative 1.3. That was the negative 4/3 we got when we calculated it, but divided out, it's about 2, comma, negative 1.3. So I go right 2 down negative 1.3. I'm drawing an open circle. And again, just get it pretty close to where it is. I know mine is probably not exactly at negative 1.3, but it's in between negative 1 and negative 2, so it's good enough. And then the x-intercepts and the y-intercept, those are going to be closed circles. So the x-intercept is at negative 2, comma 0. And I'm going to fill that circle in. Do not leave it open. Make sure it's closed. And so just simply go to negative 2 on the x-axis and put a dot. And then for the y-intercept, I already used red. Same idea, it's a closed circle or a filled in circle at 0, comma, negative 0.3. So that's like barely below the origin, just a tiny bit. Just down from the origin just a little bit. 1/3 of the way down, between 0 and negative 1. And now we have to draw our graph. So now we're going to use solid lines. And the thing to remember with this hyperbola that we're graphing is it's going to be these two curves, and they're not going to cross the asymptotes. They're going to be really, really close to the asymptotes, but they're not actually going to touch them. And I see these 3 points, the x-intercept, the y-intercept, and then the whole. They kind of give me a little guide as to where one of the curves is going to be. So I'm going to start by the asymptote on the left. I'm going to hit 1 intercept, 2 intercepts, hit the whole, but then skip over it and then keep on drawing it down towards that other asymptote. So it's important that you skip over that hole. I need to see that you realize that a hole is open, that the line doesn't actually, it's not defined at that point when x is 2. So skip over it, even if it's comically larger than it needs to be. That's still better for me to see that you've recognized there's a gap right here, this hole in the graph. Now, is that my only curve on my hyperbola, do you think? Nope, there's one other. But I don't know where that other one's going to go because I don't have any points, right? It could be up here, could be up here, could be down there. Where's it going to go? Well, these hyperbolas are always going to follow a similar pattern where whenever you jump to like the other side of a vertical asymptote, it's going to flip whichever side of the horizontal asymptote it's on. So basically, think of it jumping diagonally. So because this one's in the lower left corner, I know that this next one's going to be in the upper right corner. And so even though there aren't any points to guide me, it's still going to follow that same pattern of starting by one asymptote and then reaching towards the next asymptote. So I'm going to start up by this green asymptote here and then just curve it towards that red asymptote. So I'm not crossing them over. I'm not actually touching them. I mean, you can get really close, and it's okay if you do accidentally hit the asymptote with your marker, just as long as you realize it's not crossing it over. And it's going to be in these opposite corners, just like I've got up on the board. Yes, sir? So there won't be any other holes anywhere else, like on here for this other quadrant. And because these asymptotes are kind of like blocking off this curve from the x-axis and the y-axis, it won't have an x-intercept or a y-intercept, right? It's never going to actually touch it, this part on the right. And there are no more holes, and so we don't have a value. If you wanted to, we could take a number, some x value, like 10, for example, and I could plug 10 in to like my original function here and see what we get, like even in the simplified one. Let's see, if I plugged a 10 here, that's going to give us 12 over, put a 10 here, that's 20 minus 7, is 13. So 12 over 13. So that's just under 1, right? It's approximately, I don't know, let's say that's 0.9. So when x was 10, we got like a 0.9. And looking at my graph, we can tell that, oh yeah, that would be right at just under 1 a little bit, because isn't our asymptote at 0.5? So it would be just above 0.5 at 0.9. And so you could do like the t-chart again and get additional points, but I'm fine with you just giving the general shape. We know this is how it's going to look. I mean, even without me knowing that point, I still hit it on my graph just by knowing, oh, the curve's going to approach those two asymptotes. So you don't need to worry about additional ones. And that's why we do have you graphing the x-intercept and the y-intercept, is just to get some points on the graph, because you really need at least one to know which two like corners or which two quadrants your curves are going to be in. Any other questions on graphing any part of this hyperbola? Okay. Well, the rest of today is just to practice this. All right, I've got a wonderful worksheet here for you that's going to be very similar to what you can expect on your test on Friday. And there are two sides to this sheet that I want you to work on right now. The front is simply identifying those 5 properties, just like how we started off today with the warm-up. Just identify the asymptotes, the intercepts, the holes in the graph. So you're just calculating them. On the back, you got graphs. So the back, you're putting everything together. So on the back of it, you have to identify all 5 of those pieces and then graph it as well. Plot them on the coordinate plane. That's your classwork for right now. We've got 53 minutes for you to get cruising. All right, you can help each other out. You can use your notes. You can phone a friend, ask me for clarification. But this is where the learning is going to come in for you. And so really want you to focus on trying these, looking back at your notes, and not being afraid to make a mistake, and not just sitting there being like, oh, I don't know what to do. We've just done a whole bunch of problems from Friday and this one today to really help guide you. Just try to do those steps with these new problems. And I promise you will be learning. You got this.